Hey guys, today's lesson is on measurement in electric circuits. So how do we measure energy in electric circuits? Well, we have three different measurements that we can obtain. We can talk about the current that flows through a circuit and we can measure that. We can talk about the electric potential that's in a circuit or voltage and we can measure that. And we can also talk about resistance in different circuits. Now remember, there are two types of circuits that hasn't changed. You have a series circuit with only one pathway, and you have parallel circuits that have more than one pathway. Current is the number of electrons passing a point in a circuit every second. So you can think about it as the rate of flow of electrons. So how many electrons are actually passing by a certain part of the circuit at any given time. Okay, we measure it in amperes. We usually call it amps for short, and it's represented by the letter A. So current is the number of electrons passing a point, in a circuit every second. It's the rate, it's the speed at which the electrons are actually flowing. The symbol for current is actually the letter I. Okay, so when you're talking about current, you can actually just use the letter I to refer to it, and it is measured, the unit of measurement is amps. Okay, so amps does not represent current, it actually represents the unit current is measured in. Electric potential or voltage is the force that moves or pushes electrons through a circuit. Remember, every circuit has a power source, and that power source is either the wall outlet or a battery. And inside, let's say, for example, the battery, you have a chemical reaction occurring that's converting chemical energy into electric energy. And then once that happens, the electrons leave through the negative terminal and return to the positive terminal. Well, they need a push to leave the battery source. So however powerful the battery source is, or the wall outlet, whatever that surge is, that's going to be the voltage that's actually flowing through your circuit. Voltage is measured in volts. The symbol for volts is V. So again, this is the unit. So if you are measuring voltage in a circuit, you are measuring it in volts using the letter V. Resistance is the last measurement that we talk about in circuits. And resistance actually resists or reduces the current in a circuit. So it actually slows down that rate of electrons. And remember, when there's too much current, too many electrons moving through the circuit too quickly, that can be dangerous because it can cause an electrical fire. So there are safety features that can be put into circuits like circuit breakers or fuses that can help actually slow down the current in a circuit to ensure that you're not going to start an electrical fire. Resistance comes from one of those safety features. It resists or reduces the current in a circuit. The more loads or devices that you have in a circuit in series, obviously the more resistance that's going to be present. Okay. So what it does is it converts electrical energy into other forms of energy, which slows down the current or that flow of electrons. Okay, and resistance, you can use the letter R to represent it. It is measured in ohms. So ohms is the unit that we use to represent resistance. Now, measuring voltage and current in circuits is a little bit different. We use two different types of equipment. A voltmeter measures voltage in a circuit, and an ammeter measures the current that flows in a circuit. And the way that we wire them in circuits is also a little bit different. So a voltmeter is connected to a circuit in parallel between 2 points. And I'm going to show you what that means. But that means that when you're drawing your circuit diagrams and the question asks you to include a voltmeter, that voltmeter actually has to be drawn on top of your load. Whereas an ammeter is connected to a circuit in series. And so let me show you what that looks like. Okay, so in the last slide, we talked about how voltmeters, which measure voltage in circuits, are actually connected in parallel to either the battery source or the loads or devices in your circuit. And I just want to show you what that looks like. If I were to ask you to draw a voltmeter on this light bulb in this series circuit, your voltmeter would have to be drawn, even though this is a series circuit. I can tell because there's only one pathway for electrons to flow. The voltmeter, to measure the voltage of this light bulb, has to be connected in parallel. So what you're going to do is you're going to actually draw the voltmeter on top of your device, right? Or you could have it on top of your battery. So depending on what the question says and where it's asking you to place the voltmeter, it has to be connected in parallel, meaning you have to actually draw it on top of the device or the battery, okay? And this is different from a ammeter, which, if I may, I'm just going to... Okay, so an ammeter, which measures current in a circuit, actually has to be connected in series. And what that means is it actually has to be connected right next to the load or the device that it's measuring the current of. And it doesn't matter whether or not it's measuring current in a series circuit or in a parallel circuit. It has to be wired in series regardless. So I've drawn two examples here. This first example here is a series circuit. So you can notice that the pathway is limited to one pathway, and I have a light bulb, and then I have wired an ammeter right here, the letter A, in series to that light bulb. So it has to come right after the light bulb to measure the current, or before, but you're measuring it right before or after the actual device, so right next to it, not on a separate branch. If you notice here, this parallel circuit, I have two pathways for the electrons to flow through. I also have two light bulbs, and these two light bulbs have an ammeter each to read the current that is going to pass through them. So it has to be connected in series, which means right next to one another. Okay, so keep that in mind when you are drawing your circuit diagrams.